Hello everybody, welcome to my presentation of the VLAN, the basic concept of the VLAN. Okay, as we know, the switch in a network will divide the collision domain, such as this one switch connected to these two devices, okay, PC1 and PC2. Okay. When PC1 and PC2 sending and receiving data from the switch, then the switch will store in the memory, okay? And then when this link is idle, then sending out. So these two PCs, PC1 and PC2, will not collide at any condition, okay? So each interface of the switch is a collision domain, but the switch will not filter the broadcast frames. That means when a PC1 sending out a broadcast, then this frame will flooding out all other interface. Okay, so all the PCs are in one broadcast domain. So if we want the switch to divide the broadcast domain, how can we solve this? Okay, the VLAN is the solution. Okay. So in this chapter, we will discuss the basic concept of the VLAN tagging and then discuss the different link types and then how to configure VLANs on Huawei switch. Okay. First, this is the length limitation. Okay, we have ever discussed that the LAN, okay, all these switches connected as a LAN, and then all the devices are connected to switch belong to one broadcast domain. This red arrow means a broadcast frame sending out this PC. Then this PC or this frame will flooding out all the other interface, and then all other PCs can receive. Okay, then if we want some PCs to form one broadcast domain, that means some PCs sending out broadcasts, only some of these PCs received, and others, for example, this group cannot receive the broadcast sending by this PC1. Okay, then how to solve this? We use the VLAN technology. In this VLAN technology, these three PC formed one group, and the other three PC formed another group. Then one group is one broadcast domain. That means the PC in group 2 sending a broadcast frame, then only the other PCs in group 2 can receive it. And the PCs in group 1 cannot receive. Okay, that's what it means group 1 and group 2 are different broadcast domains. Okay, this is the VLAN's concept. Okay, and then how to implement VLAN? We got an improvement of the Ethernet frame. Okay, this is the basic Ethernet frame. Okay, basic Ethernet frame. This basic Ethernet frame, that's the source MAC address, destination MAC address, and then the type, figure out what is in the data. Okay, the layer 3 protocols, and then frame checksum. Okay, this is untagged frame. And when we deploy the VLAN, we insert a tag between the MAC address and the type. Okay, this is a tag. How to use this tag? This tag just to identify what VLAN this frame belongs to. Okay, this is a VLAN. Okay, VLAN ID is inserted, but we need to figure out this is a tag, not a type. So in here, there's a TP ID. The value is 8100. This value, just figure out this is a tag. In this tag, we got a VLAN ID. Okay, then figure out what this frame belongs to, what VLAN this frame belongs to. Of course, there's still a type to figure out what is the data, what is the layer 3 protocols. And this frame is the tagged frame. If we got this type of Ethernet frame, then we can support multiple VLANs on one physical link. That means, okay, for example, this is the example. For one switch, okay, then we got many PCs, okay, and by default, these two PCs belong to one broadcast domain, okay. If we want to divide the broadcast domains, then we can divide this PC1 and PC2 are different. For example, broadcast domain 10, broadcast domain 20. Okay, that's VLAN 10 and VLAN 20. And if there's another switch, then we also have a VLAN 10 and VLAN 20. There are two broadcast domains, okay. And then if we want this to switch, the VLAN 10, broadcast VLAN 10 on this switch are connected to this switch. And then if we connect as this, then PC1, PC2, and PC3, and PC4. PC1 and PC3 can communicate each other, okay? And if we want a PC2 and a PC4 to communicate each other, we also need a connection, okay? Okay, this is the basic solution, okay? But this is not a good solution. Each VLAN, we need a physical connection, okay? If we can using one physical connection, and then there's many logical connection between these two switches. How to solve this? We use the tagged frame. To carry many VLANs frame, Ethernet frame on one physical link, we should use the tagged frame. Okay, this is the improvement of the basic Ethernet frame. Okay, then after this change, okay, the physical link of the switch or the interface of the switch have different types. First is the trunk interface, and another is the access interface. As we know, if all the frames belong to one VLAN, this is the access interface, okay? In this access interface, the Ether frame did not need to be tagged, okay? Because untagged, we call untagged. Because all Ethernet frames on this link are belong to one VLAN, so no tag needed. Of course, usually the PC, the host, did not support a tag. And when this link is belong to two switches, okay, and usually on this link we need to carry more than one VLAN, okay. So when two switches want to identify which VLAN this frame belongs to, so we need a tag. Use tag to identify which VLAN this frame belongs to. Such link we called trunk, okay? Called trunk link. That means the trunk link use the tagged frame and the access links use untagged frame. Okay, this is the result. Okay, and then we got another concept, port VLAN ID. Okay, as we know now, host sending and receiving frames without a tag. Then, how do the switch knows which VLAN this host belongs to? We can configure a port VLAN ID on this interface. After we configure this port VLAN ID is 3, then all the frames receiving and sending on this link is belong to VLAN 3. Okay, and the other access interface is the same concept. And this link connected to switches. We know usually this link carrying more than one VLAN, such as the VLAN 1, VLAN 2, and VLAN 3 are all carried on this physical link. So this is a trunk link, okay? This is a trunk link. Okay, so but the trunk link also have the PVID, okay, port VLAN ID. That means this trunk link can carry frames without a tag and with tag. If the frame sending out without a tag, that means this frame belongs to VLAN 1. And if receiving a tag, receiving a frame without a tag, that frame is put into the VLAN 1, also put into VLAN 1. Okay, this is the VLAN port VLAN ID, the concept of port VLAN ID. It's used for the frames without a tag. Okay, either the access link or the trunk link. And by default, the switch interface are all set to 1s of the PVID. The PVID of the switch or interface is set to 1. Okay. And then first we got the access link. Okay. The access link, we have the concept, is connected to PCs. Okay. Usually is connected to PCs. And on this link, we sending and receiving untagged frames, okay, and which interface, which VLAN this interface belongs to, is configured by the switch, the PVID. The PVID is 10. That means this interface belongs to VLAN 10. Okay, And then when this frame, untagged frame, is receiving by the switch, then switch will tag this frame with the VLAN 10, okay? And then finding the MAC address table. Okay, the MAC address table now got the VLAN attribute. And then find the destination MAC on the MAC address table and only the VLAN 10s, only in the VLAN 10. And then forwarding out, okay, forwarding out on the VLAN 10s. Okay, this is the destination MAC. Okay, then sending out. Of course, when sending out, this is the access interface will untagged. That's the tag will be stripped and then sending out. And if this interface is belong to PVRD2, that's not the 10. So this frame will never forwarding out an interface belong to other VLANs. That means the VLAN 10 and the VLAN 2 is separated, okay? It's separated, okay. And there's an exception. There's an exception. That's on untagged on access interface, the switch can receiving a frame with the tag. The tag is equal to PVRD. Okay. If sending a tag is not equal to PVRD, is not equal to 10, then this frame will be dropped. But if sending out an tagged frame with the tag equal to the PVRD of this interface, this frame will be received by the switch, and then finding the MAC address table. Okay, then sending out. Okay, this is the access interface. Okay, then another interface is the trunk interface. In the trunk interface, usually the frame is sending out with the tag, okay, with the tag. In here, in this topology, the link between switch A and the switch B is the trunk link, okay? And the between switch and the host are access link. So when the host sending out an untagged frame, then the switch gets this frame. Of course, the PVRD of this interface is 10, so the switch will get the frame with tagged 10, and then finding the MAC address, and then finding the destination MAC is host C, and then forwarding out on this interface. Okay, usually the switch sending on trunk link with the tag. Okay, but there's one exception. That's this interface sets the PVRD to 10. That means when the frame belongs to VLAN 10 is sending out this interface, then this frame will be untagged. That means with untagged frame we are sending out. And then on switch B, the PVRD is also the 10. So an untagged frame received on this trunk interface will put into VLAN 10. And then searching the MAC address with VLAN 10 attribute in switch B and then sending out. Of course, this access link, then untagged frame is sending out. Okay, this is the trunk link, and then if there's another VLAN 20, okay, then VLAN 20 is sending out to the switch. Okay, the switch received an access link. This access link interface, the PVID is 10. Then this frame will be tagged as a 20. Okay, tagged as a 20 in the switch, and then the switch searching in the MAC address table, and then we are sending out in this trunk link. And this trunk link, the PVID is 10, not equal to 20. So the tag of 20 is carried, and then sending to the switch B. And the switch B got this ether frame and see the VLAN 10. Okay, then searching the MAC address with the attribute VLAN 10, and then sending out certain interface. Okay, this is how trunk interface is worked. Okay, and another on the trunk interface, there is a concept of PVID. Also, there is a concept of the VLAN list. A VLAN list that you must list the VLANs that are allowed to pass on this trunk link. Okay, there's a VLAN list to list all the allowed VLANs on this trunk link. Okay, this is a trunk interface. And last port type is a hybrid interface. The hybrid interface is a combination of the access link and the trunk link. You can configure the hybrid link as the access link, or configure the hybrid interface as the trunk interface. Okay. For example, you can configure this interface as a hybrid and then list the untagged interface, untagged VLAN as the VLAN 10. Okay, then all the interface received, of course, there are the PVID received on this interface is configured as the VLAN 10, and then we are sending out other VLAN 10 interface. Okay, in the hybrid, we should configure 3. Okay, one is the PVID, and second is the tagged VLAN. Third is the untagged VLAN. Untagged VLAN. So on this access interface, you can configure the PVID as a 10 and configure untagged VLAN is 10. Untagged VLAN means when sending out the frames belong to VLAN 10, then no tag is carried. PVID means when receiving a frame without a tag, then this frame belongs to VLAN 10. Okay, so this action then is equal to the access interface. Okay, the access interface only needs to configure one parameter, that's the PVID, and 10. And then the PVID says when receiving a untagged frame that's belong to VLAN 10, and when sending out, yeah, it's the VLAN 10 and the tag is stripped. Okay, just as the hybrid with these two parameters. And for the trunk interface, we also can configure the PVRD. For example, PVRD is 10, and then we can configure a target list. That's 10 and 20. Okay, then all the frames sending out this interface will with tag. Okay, VLAN 10 and VLAN 20 will with tag. And when receiving, also with the tag VLAN 10 and VLAN 20 were received. If we received a frame without a tag, then this frame will belong to VLAN 10. Okay, and this is just like the trunk. Okay, trunk also needed to configure two parameters. One is the PVRD, and another is the VLAN list. VLAN list just means the VLANs, the frames that belong to which VLAN can allow to pass. Okay, this is VLAN list. Of course, all this VLAN list is with tag. Okay, so the hybrid is the combination of the trunk and the access. Okay, this is a hybrid. And then when we configuring VLANs, how to assign the VLANs to the interface. And usually, most conditions we use the port-based. That means we just configure VLANs on this port. For example, in this example, VLAN 5, VLAN 10, then VLAN 5 belongs to interface 1 and 7, and then 2 and 9 belong to VLAN 20. So these two hosts, host A and host C, belong to one VLAN. That's the one broadcast domain. And host B and host D belong to another broadcast domain. So when the host A is sending out a broadcast, only host C can receive. Okay, host B and host D cannot receive. And host B sending out, the host D can receive. And another two cannot receive. Okay, this is port-based. And the port-based is statically configured in the port. Okay, any device connect this port then belong to certain VLAN. And another solution is configured as the MAC-based. MAC-based, that means the host A and host C. For example, host A is the address, is this address. Then, when this host A connects to a switch, any interface, then if the switch A receiving a Ether frame with the source MAC address as this, okay, then this interface is belong to certain VLANs, VLAN 5. Okay, of course the C means host C also belong to certain 5, VLAN 5. What interface connected to? That's not mine. Okay, this is dynamically. That means when when a host connect to certain VLANs, certain interface, then this interface will change to VLAN 5. Also, this is VLAN 10. Okay. And this is a Mac-based, but sometimes Mac-based configuration is a little complex. You need to find what is the MAC address of each host. Okay, this is difficult. Okay, this is difficult. So this is a dynamically assigned VLAN, and other is the same. The other method is the same. All decided by what is contained in the ether frame. This is based on MAC address, and this is based on IP address. Okay, the source IP address, and this is based on the layer 3 protocol. The layer 3 protocol belongs to IP, then this frame belongs to VLAN 5. If layer 3 protocol is IPX, then belongs to VLAN 10. Okay, and the policy based, that means you can combine all these three. Okay, combined by the layer 3 IP address and the layer 3 protocol or MAC address and so on. Okay, all the interface and so on. Okay, this is the policy based. It's of course this is the most complex method, but usually in our working network, the port based is most widely used. Okay, then we have discussed the concept of VLAN.